Do you know how your program written in C or C++ get turned into an executable file you can actually run on your machine? Let's uncover the simple 4-step journey from your code to real executable binary. Let's first understand the problem. Here the problem is we write code in high-level language. Think like printf, loops and if statement. That's great for humans to understand. But your computer CPU does not understand any of that. It only speaks binary, just 0 and 1. So we need a translator. In fact, not one, but a whole chain of translate. Together they form the build pipeline. And it has 4 main stages. The first stage out of which is the preprocessor. Its job is simple. Handle anything starting with hash symbol. For example, when it see has included std.h, it goes and copies all the code from that line right into your program. Same with has defined macros. It just replaces text. After this, you end up with one giant CPP file all ready for the next step. Now comes the real star, the compiler. This is where translation begins. The compiler takes your pre-processed CPP file with extension .i, turns it into assembly language. Assembly is like the computer assent. It's much closer to binary, but still written with word. Human can kind of read like move or add, but compiler do more than just translate. They also optimize your code, remove dead code, reordering instruction, and making things faster. So you don't just get working code, you get efficient code. And next is assembler, step in. Its job is straightforward. Take the assembly code and convert into a raw machine code. The actual ones and 0 your CPU can run. Each assembly instruction become a binary pattern called an opcode. The result is an object file. Think of it as a puzzle piece. It has real binary code, but it's not a fully programmed yet. The final translator is the linker. Your program usually depend on other code, like the standard library for printing text. The linker job is to take your object file, pull in all those missing pieces and stitch everything together. If something is missing, you will get a linker error. But if all goes well, the linker produce a single complete file. And finally, when you run, you will generate a exe. As soon as you will execute it, and finally when you run, see your operating system loads the binary into memory and your CPU start executing those 1s and 0 at lightning speed. That's how your source code become a living program. The question for the user is that when you have an executable, whose role is to take it to the CPU? Please answer in the comment. We will discuss this in upcoming video. So the 4 steps are preprocessing, copy and replace, compilation, translate and optimize, assembly, convert to binary, linking, stitch everything together. From high-level C or C++ code all the way down to low-level binary CPU love. If this made clearer, hit the like button. It really helps the channel, and subscribe for more simple explanation of how computer really works. Thanks for listening, and if you want to read more, go and visit compilersutra.com. And in the next video, we will see each step one by one from preprocessing all the way to the final executable. You don't want to miss it.